Hello, and welcome to the video on some set notation symbols. This is sort of an introduction to some of the symbols that we use in set notation. I'll take you through some of the symbols that we'll use to talk about what things are part or not part of a set. So this curved looking capital E, that symbol means element of. And it's used to show that a number is part of a certain set. And the E with the line through it means not an element of. That's used to show that a number is not a part of a set. So first up, it says it in here, show that a number. These symbols are used for numbers. And I'm pointing that out because some of the other symbols that we use are used for sets and subsets and not for numbers. But I'll show you how these things are used. For instance, if a number is actually part of a set, like 4.32, that's a terminating decimal, that makes it an element of, it is part of the set of rational numbers. So I can say that 4.32 is an element of rational numbers. That is a true statement. I can also say that 4.32, which is not a positive or negative whole number, is not an element of integers. Integers are the set of positive and negative whole numbers. Or suppose you were given a question on a quiz or on a handout that asked you if this was a true or false statement, you could say that this one was true. It could be that one is written out. If it said that 4.32 was an element of integers, that would be false. And similarly, I can say that the square root of 3 is an element of irrational numbers. It's a root, and if I test, I know that it's not a terminating number. So based on the fact that that's a root, that's most likely an irrational number. And it's not just one. It turns out that root 3 is also an element of real numbers. All the numbers we're dealing with are, except if you remember infinity or square root of a negative number. So that one is a real number. I had said that those ones are only used for numbers. These sets, or these set notation symbols, this one here means is a subset of. It denotes that a set is entirely within another set. Every element of this set is automatically an element of that other set. That this is the bigger one and that is the smaller one. And the same symbol with a line through it means is not a subset. So there are two ways to use these. One, for the not subset, that is. So let me explain. For instance, n, the set of natural numbers, is a subset of rational numbers. Why is that? Well, if you remember the graphic organizer, the set of n is literally inside the set of q. It's a smaller set that lies within q. So that is called a subset. But the other way to think of it is that natural numbers are positive whole numbers, and rational numbers are any numbers which terminate. And if it's a whole number, it doesn't have any decimals. It for sure terminates. It has to. So automatically these are automatically a part of this set, and this set is larger than this one because it also contains numbers that are not natural numbers. Now, there are two ways to use this not subset of. So either it could be something like this. Z is not entirely within Q apostrophe irrational because no numbers that are in the integer set are part of the irrational, not even one. So if you're in one, you're automatically not in the other. So that's one way to use it, and that is true. This is another example that is true. The set of natural numbers is a subset of the set of natural numbers plus 0. This is a set that has one additional item. So all of these are automatically in that set. But another way to use this not subset of is to show, I can say that this larger set is not a subset of n. They're very closely related, but the way this symbol works, the direction of it, shows that this has to be the larger set, and the thing on this smaller end, or the rounder end, must lie entirely within the symbol on the other side. And there are two other symbols that we use that are very similar to the previous ones. This is kind of like an inequality symbol, a subset of or equal to. And this is not a subset of or equal to. So when would we use this? I mean, most of the time this is not really useful because all of the sets that we talk about are strictly subsets, or they aren't. There's no case of a thing that is a subset or equal to. But in some cases that could come up. And an example of something that is a little bit different where this could come up, I mean, you can use it the regular way. N is a subset of or equal to all the rational numbers because it's a subset, because this is a subset or equal, and it matches the subset. I suppose you could use it for the same set, like integers are a subset or equal to integers because they're equal. But a more interesting time that you can use this is for other sets. Like, for instance, the set of people in our class who will end up getting over 80% on the final exam is going to be a subset or equal to the set of all the people in the class. So it's at least a subset because anybody who is in this group has to have been in our class. But maybe it could be that everybody in the class does. It could work out to be the entire class. And if that's the case, it would be not just a subset, it would be or equal. It could be that every single person does. Hopefully they do. And that's some of the symbols that we use for set notation.